couple times. Then our performance starts to go down. Our performance starts to decline. That's weird. Okay. Our performance starts to decline because we get bored, we get sick of it, and we start to decay, slow down, and get kind of crabby. In fact, one thing I've noticed as a human is if I do something once, having to repeat it, like a paper or a code, a problem set, like if the document doesn't save right, it is way harder to do it the second time. That makes no sense as a human, right? You'd think it would be easier to do it the second time, but you're so frustrated because we hate to repeat ourselves. So computers, on the other hand, they can just repeat and repeat, and they do it quickly and flawlessly, typically. The while loop is just an if statement on steroids. It's a great way to think of it. So you had used an if statement where you said, if some condition is true, run this code in block. Well, the loop does the same thing, only at the end of the block, instead of going to the next line of code, a while statement comes back up to the while loop and rechecks the conditions to see if they're still accurate. So a while loop is just a steroid version of the if block. So you're pretty familiar with it already. The classic use case for a while loop is for ID10T errors, as we like to call them. And so, for example, you might be checking to see if the user has entered the correct password. And until the user enters the correct password, you keep repeating password, 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 and you wait for the user to enter the correct password. And then your code will move on. Until they enter the correct password, it's stuck in that loop. Another example that might not be an ID10T error would be when you play a game and while is alive, you run code that keeps the game playing while the player is alive. Once you change that condition to not alive or is alive false, it will fall out of the loop and move to the end game sequence you may have coded. So a conditional in a while loop is often unknown when you write the code and isn't known until you're in the middle of running it, or what a programmer might say, we don't know till we're running it, till runtime, how long that loop is going to run. There's another loop we'll learn tomorrow called the famous for loop, and the famous for loop, you usually know how long the loop is going to run, or the conditions are known, and you execute a loop in a more known pattern, and a while loop tends to be unknown until it's happening. You don't know how many times the user is going to mistype in their password or type their password in wrong. So you just got to keep repeating till they get it right. It's kind of unknown until it happens. There are 3 key steps to writing a successful loop. By the way, all loops, we'll see these structures in the for loop tomorrow. But for the while loop, and these are in the same order, by the way, as the for loop tomorrow. You first have to initialize the loop. Then you test the loop's conditions. And then somewhere, hopefully, you change the loop's variable. You change the status of the loop and then repeat it. So looking at that block of code, you can see we start a count at 1. We check the condition. So is 1, the current state of the count, less than or equal to 10? Well, yes, 1 is less than or equal to 10, so it's going to run the code in the block. It's going to system.out.println 1, and then it's going to increase the count to 2, and then run that again and again and again and again. This is a lot of order. Sorry about that. Another way we can do this same kind of looping structure is a do while loop. A do while loop is not used very often, to be honest. It's kind of a less used loop structure. So I'll go over it pretty quickly. But instead of putting while at the top, you put do at the top, and then you have that open curly brace, closed curly brace structure. And then at the bottom of the loop, you check the status. So it's possible. So it's kind of like the get one free loop structure. So if you want the loop to run for sure once, for example, with a password program, maybe you want it to for sure run once, you would do it with a do while loop. You can also do a password program in a while loop structure as well, which is what you're going to do today for your assignment. But again, just a different approach. It's the get one free do while structure. Okay. Hopefully on your screen, I'm going to, yeah, it did work. What is going to be the output of this code running? So would you please pick A, B, C, or D, I believe it is. Oh, sorry, it just gives you a range. Sorry, it doesn't say A, B, C, or D. It just says some different ranges. So which range is going to be accurate? Only one of you have responded. Come on, wake up, folks. 2, all right. Now people are getting it. Good. Oh my goodness, I hope my lectures don't put you all to sleep. It is tough at 8 in the morning. Got 15 people responded, yay. I think some people are having computer problems, legit. I have some people in the slide deck, but not in the pair deck. Oh, I see that, I see that. Yeah, that struggle is real. By the way, we have a range of answers. That's kind of interesting. Oh, can you see that? I don't know if you can, it doesn't look like you can see that. I was hoping you'd see the answers, but you can't. All right, let's run that code. And we're going to run it in something called the Java Visualizer so that we can see, well, first let's see the answer. It's going to output that 0 through 4. Now let's see why it does that. Okay, so it is going to set a variable count to 0. So while 0 is less than 5, it's going to run the code. And as you can see in the output, it outputted the 0. Then it's going to recheck the loop, and it met the condition. Now count is at 1, and 1 is less than 5. Now it's at 2, 3, 4. Now here's the tough one. Oops, sorry, we should output it. Now here's the tough one. It just is going to reset now the count to 5. So the variable count actually equals 5. The question is, does it get outputted? And the answer is, while count, which is 5, is less than 5, is false. 5 is equal to 5. 5 is not less than 5. So it's going to stop running the loop. Notice how it jumped to line 13. It exited the loop and never outputted the value of the count. So the count went from 0 to 4. It did go through the loop 5 times, but because of that darn 1, or because of that darn 0, sorry, the OBOB, it did not behave like you might have expected, and it went from 0 to 4. So that's how that worked. Here are the steps in creating a loop. And you can see my slides got a little out of order. Sorry about that. The first step is to initialize the loop. The second step is to test the loop. And the third is to change the loop variable. And by computer science tradition, you can do it at the top, but when we iterate through a loop, we tend to iterate it on the bottom. It's just kind of a pattern, like a best style pattern that most of the time we use. There are exceptions to every rule, of course. There wouldn't be hackers if there wasn't exceptions to the rules. But overall, we the best style dictates that you iterate your loop at the bottom of the loop. That's the classic way to do it. Now I have some questions for you about what's missing. So here's the correct structure of the loop. Now when you look at this block of code, something is missing. What's missing? Hopefully you have a screen that, is it a 1, a 2, or a 3? It's asking you to tell what's missing. Is the initialization missing? Is the test missing? Is the change the variable loop missing? So type in that number, hit return, what's missing? Ah, I got some funny replies. My favorite has got to be how I'll tell you when it's over. Some funny replies there. These people are awake. 12 responses, all right. What's missing? "14 responses. "15 responses. Almost everyone. My favorite response is plus plus is missing, and that is correct. It is the 3, changing the loop variable. So nowhere in the loop, this loop, does it change. If I were to run this code, it would forever say count 0 and just fill the screen with count 0. In fact, if you ran it on some IDEs, it wouldn't even compile. It would call it an infinite loop without doing anything. You can have infinite loops, but they have to do something, and this one just does nothing. So it would time out a lot of systems and be bad. But the answer is the change in the loop variable. So number 3 was the correct answer. Let's look at another one. What's missing in this one? Is nothing missing? Is the initialization missing? Is the test missing? Or is the change in the loop variable missing? What's in this one? This one's really tricky. "13 responded. "17 responses, and the correct answer is 1, the initialization. Now, what's weird about this initialization is you can see on line 7, it does initialize the variable, but it initializes it within the while loop, constantly resetting it back to 0. So the way this loop would run is, first of all, there would be no initialization on line 5 and the program would crash. If somehow the program continued, it would constantly reset the value to 0, but it wouldn't even get past line 5. At line 5, it would say you have no variable named count. I don't know what count is. Count is undefined. So the answer to this question is that the number 1, the variable, is not initialized. Next one, what's missing there? Find the bug. 11, 12. No bug. No initialization of the variable. No test condition. No change in the loop variable. This one, the bug, is that we are not testing the condition of the loop variable. So that would be number 2. We don't test the condition of the loop variable. This is a bug. While true will run forever. It would start at 0 and count up forever. In fact, it would run out of digits and then go to negatives and then count all the way through the digits and keep going. It would be a classic overflow error, and it would just go on forever and ever. And when we had real fast computers, we used to do this just because you can turn this bug into a feature. So it actually is somewhat of a feature that you can have a while true loop, and we'll cover that in a little bit. The next thing I want to cover, though, is when you look at this code right here, notice that this code counts by 2. So the output we want is we want it to go 0, 2, 4, 6, 8, 10. Notice the count iteration right underneath the system.out.print has count plus equals 2, which is the same as saying count equals count plus 2. They're missing the darn while header, though. And we do want the 0, and we do want it to be 10 inclusive. So we want it to go to 0 space 2, which, by the way, the count does include putting the number down and then putting down a space. I wish they would have been more accurate, and they got caught a little bit in proofreading. There actually would have been a space after the 10. You notice it goes 10 quotation mark, and it should be 10 space quotation mark. But anyway, that's a very, very small detail. Let's look at this challenge. What would be the correct while loop? A, B, C, or D? What would be the correct while loop for that statement that counts by 2 instead of counting by just 1? Nicely done, folks. The correct answer to this one is that you need to include the 10. So when you hear the word inclusive, think of that equal sign. Being inclusive is making things equal, right? Is kind of a little cheat. So it would be the C, which is count less than or equal to 10, because we do want the 10 on the screen. We could also have gone less than 11, and it would have included the 10, for example. But you can count in patterns other than just one in a while loop. In fact, you can do all kinds of things in a while loop. You can make all kinds of conditions in that while loop, including using strings, like for password. But if you use strings, don't forget to use the dot equals, not the equals equals, because dot equals has a different meaning than equals equals. Equals equals compares, are they the same object, just different aliases? Kind of keep that in mind for today's assignment. But for primitives, you can just use equals equals or the greater than, less than operators. Now let's talk about a while true. Oh, I did leave it in the lesson. That's good. A while true kind of hack. Typically, when you're coding, it's considered bad style to do a while true or have an infinite loop that you can't break out of. However, some programs, especially robot programs, robotic C programs, they're in a while true loop, and the loop will stop when you turn off the robot. So as soon as you power on the robot, you initialize a bunch of stuff, and then you start the robot's action inside a while true loop. Some games are in a while true loop and only stop when the entire game exits, and they use a break statement for that. But a while true statement is a structure that is legitimate in certain circumstances. And for the uber geeky out there, you can learn about a structure called a loop and a half, which always uses a while true loop and uses the break statement. There's a command in Java, break, B-R-E-A-K, um, uh, and it will break out of whatever loop you're in and just go bounce you one loop back. Break out of whatever loop you're in. And the loop and a half structure does use that. So while some consider it bad style to be in a while true loop, others consider that bug a feature. Just for fun, what I'm going to challenge people to do is, and we're going to need to go there today anyway, if you wouldn't mind going to Replit and make a new REPL by either clicking on the new REPL command or the plus command. Either way. And we do have time for this. That's good. We're going to see how far we can go. I'm just going to call my, oops, bad style. Call my how far. And I'm going to create this REPL. And at school, we tend to use the actual computers, and then it's more about the speed of that computer. We even noticed in the past that people who are running Chrome would slow down, and then people would load a bunch of Chrome windows to slow it down even more. Those were good times. Oh, I miss the old days. But what I'm going to ask you to do is make a program that sets a variable count, and then we're just going to do a while true loop. I know I'm typing this kind of fast. And in that while true loop, we are going to system out, and I'm just going to go count. I'm not even going to say anything else because it will slow it down. And then I'm going to go count plus plus, and that's all I'm going to do. So just, I'm going to blow this up a little bit just to make it a little easier for people to read. All I'm doing is making a program that counts and just keeps going forever. And then, as soon as you get that coded, start writing it. I'm at about 200,000. I'm now at 400,000. I just passed 1 million. All right, I think most people have gotten it. I know some of you are still struggling. To stop the counting, feel free to press the stop button, and it will eventually exit with a 143. But again, feel free to hit that stop button so you can have your computer and you're saving. I bet your Replit loves this when we did this. A lot of processing power going to doing no good work, right? But still kind of cool to just see how far it got. Just if for those who are curious, I was able to get to 1.5 million. So I got to 1.5 million in that 2 or 3 minutes that I was running that while loop. Kind of cool. Again, feel free to leave that up because you might want to use that base code, or at least that start, for your coding assignment, which you're going to have in, I'm going to give you in just a few moments. Sorry, we do have one more topic. That's how do you code trace a loop? So we are going to watch a video. It's short, only a minute.
Sarah to write and understand several loops, and it will often happen to you that you have a loop that's really mysterious. And I'll give you an example. Here's some code that comes from a program that you will improve in a bit to solve a common problem, namely to identify reverse digits in a credit card. So let's see what this code does. What you always want to do is get out a sheet of paper. Here's my sheet of paper. You make a table, one column for every variable. There's a variable n, there's a variable sum. Now, it's always a good idea to take a marker. I like to use a paperclip to mark where we are. So we set n to 365. We set the sum to 0. Now we enter the loop. Is n greater than 0? It sure is. We get to this statement. Now we need to compute n modulo 10. That's the last digit of n. That would be 5. And now we have a new variable. We record it. We put in the 5. Moving on. Sum is sum plus digit. N is n divided by 10. It's an integer division, so we discard the remainder. We move to the top of the loop. Is n greater than 0? Compute n mod 10. 36 mod 10 is 6. Store that in the digit. Sum is sum plus digit. It is 11. N is n mod 10. Now n is 3. Back to the top of the loop. Is 3 greater than 0? It barely is, so we stay in the loop. Now we need to take 3 mod 10. That's 3. Add it to the sum. Divide n by 10. That's an integer division, so now we get 0. 0 is no longer greater than 0. We fall out of the loop and go to this statement. And what are we printing? We're printing 14. Okay, what was 14? Well, we've computed all of the digits of the number 365, the 3, the 6, the 5, and we've computed their sum. 14 is the sum of the digits. And that's almost what one needs to do in order to verify a credit card. You'll see in your next programming assignment what sum of digits you exactly need to do. You've just worked with Sarah to...
I love that video. That's from our CS Awesome textbook. That's originally from a class by Kai Horstman, who wrote the classic Objects First Java textbook that a lot of teachers in colleges use. Great course. Pretty cool stuff. For some of you, that demo might have blown your mind because you're like, shoot, I could have used that in previous problems that you gave us, Mr. Rode, where we had to calculate the different digits in the different places. It's a cool little algorithm there. But I like the way they talk about tracing code, which is something we are going to do with just one problem today. So inside of Google Classroom, in theory, you've had one thing, you've had some things activate. And one of the things that should have activated this morning was an iteration code tracing practice. I'm going to beg you to go to your iteration code tracing practice, click on it, and open it up. And this is the tab that opens. There are a couple of new, I don't know what you would call it, new syntax. So A gets 10, that's kind of the same. If nothing's declared, just do a minus thing, and you can continue that pattern. But you'll notice here that with iteration, it's a little different. The iteration is calculated down here. So the iteration for A and the iteration for C is going to be down in this part. There also are going to be some lines you don't need. And for whatever reason, I went with a semicolon. I don't know why. Don't ask me these complicated details, but that's for skip iterations. So that's kind of how that works. My challenge to you is to take a few minutes to code trace this problem right here, and then we're going to go over it together. So take a few moments to code trace this right now, and then we'll go over it.
Should we have our own copy?
Yeah, did it not ask you to make your own copy?
No.
I set it up wrong. Please stand by. Thank you. One second. It's coming. That's my bad. Please stand by. What? What? Something's not right.
Mr. Rody, can we just make a file and a new copy?
Yeah, you definitely can. I am curious why it's not working in Google Classroom. But yes, feel free to make your own copy. Gosh, nice to have sharp students, but I'm such a computer geek. I've got to figure out why it's not working. It's still not working. Huh. It's not giving me the option, which is really weird. Huh. The permissions are, sorry about that. You have to go up to File. Here, let me show you. You have to go up to File and make a copy. That is a total pain. You shouldn't have to do that. It's supposed, I messed something up somewhere, obviously. Google didn't mess up. I messed up somewhere. I just don't know where I messed up. And make a copy, please. Sorry about that. And thanks for the suggestion, and thanks for noticing. Make a copy and solve it. Sorry. All right. And again, sorry about that thing. I did like delete it and start over, and I was able to put it in. We'll need it tomorrow too. So I'm going to go over the answer. 10 stays the same. B is now assigned to 4, and C is null on this line. A remains 10. B is assigned to 4, and C is now assigned to 0. The next step is taking A and dividing it by B. So 10 divided by 4 is going to be 2, remainder 2, which makes the modulus really easy because they're both 2. That was kind of a freebie. And now it's going to go into the loop as long as C, which is 0, is less than B. So since 0 is less than B, we're going to go into the loop, and with 0 less than B, we're in the loop. C equals C plus 1, which is going to go from 0 to 1. And then B is going to stay 4. Nothing happens to B. And A is at line 1 iteration point, which A equals A plus 1 is 3. And you may notice that the iteration takes place after line 7 and after line 8. That might have been a confusion, and I didn't explain it explicitly. But that's why I moved it over to the other side and tried to put it on the line to indicate it means after the variable is iterated. So here, now we're going to go up and do the logic check. Is 1 more, or is 1 less than 4? Yes, it still is. So we're going to iterate again. So 4, this stays 4. This goes up to 2. Is 2 less than 4? Yep. And then we're going to go 5. 4 stays the same. This goes up. Is 3 less than 4? Yes. So we're going to have 6, 4, and 4. Now the question becomes, is 4 less than 4? No. The iteration is going to stop. So this is now my answer. So here is the correct answer, and I'll just leave it in place on this sheet for now so you can see it, especially the bottom. Here's the bottom, and that's how that process worked. And I'll leave it there if you want to go back and see it in the video. So that's the correct answer. Oh, GIFs don't work. I forgot GIFs don't work in Pear Deck. But today's assignment is called You Shall Not Pass. And what I'm going to ask you to do is mostly a typing exercise. I give you the code, but you have to type a lot of it. Sorry, I didn't give you a template on purpose because I want you to practice typing all this stuff. It's not too many lines of code. And I'm going to give you about 10 minutes of class time, plus feel free to finish this if you don't get it done. And your job is to write a password program. Don't forget, as it says on line 21 of this code, that you have to use that string equals password thing. And you're not going to use string, you're going to use the user guess. I tried not to give it completely away, but that there is some trickiness to it. So can you get that program to work that when they enter Java Rocks++, it then says access granted? So that is your goal, is to create that program. If you are able to create that program, after you do that, please go to this 1-star thing, which means it's graded, and complete the You Shall Not Pass Google form. When you complete the You Shall Not Pass Google form, I'm going to give you a grade for it to boost your grades. So please do this and get this done. On the topic of You Shall Not Pass, I want to fill you in on Asynchronous Wednesdays, or tomorrow's Asynchronous Wednesday. This is kind of easy to explain. If you have everyone has to come. It's like a school rule. Everyone has to come, and I'll check you off for attendance. If you are done with everything, I'm going to dismiss you with nothing to do. You are going to be freed. If you have late work, I am going to be sending you an email outlining what work you need to get done. So I'm going to ask you to get that work done. I'm going to stay online. I'm going to help people. I'm going to pressure people. And I'm going to be asking people to get late work done. So I am declaring a catch-up day because there are several of you who are not passing, or several of you who would be doing much better if you had completed work. And I want to make a specific time for that. This is really rare for me. I'm not into this kind of thing, but there's been some pressure to get the number of failures reduced. And there are a lot of, unfortunately, people who are struggling with their grades in this class. So tomorrow's asynchronous Wednesday is different. I hope not to make this a pattern. I hope to make this just a 1 or 2 time thing. But I am going to free people who have nothing to do. They will get a special happy email saying that when I dismiss class, you are free, take off. Other people I am going to ask to stay in the meet, and I am going to monitor them via GoGuardian and try to facilitate and help them get through work and get things done and offer you some links and some walkthroughs and that kind of thing. So tomorrow, I'm going to beg you to use that asynchronous Wednesday, especially if you have other classes that aren't meeting. A lot of you are in a lot of hard classes, so your classes are meeting. But if you have other time in the day too being asynchronous Wednesday, it would be awesome if you were to get caught up in Java and make tomorrow Java Day. So for tomorrow's asynchronous Wednesday, you shall not pass. The rest of the class period, I urge you to make in Replit. By the way, we opened the Replit tab. Feel free to use that code and just add to it and make the you shall not pass program. It does, no, it doesn't. Some future ones ask for a link. This one doesn't. So that is what is needed to be done. That's all I have. Class dismissed. I'll stay online if anyone has any questions. I've stopped the recording.